Okay, we're here to look at some conditional probability. Now, conditional probability, you're going to see it notated like this. The probability, we read it as the probability of A given B. So the probability that event A happens given that event B happens. So this right here is the formula essentially, and this is provided on like the geometry formula sheet. So you don't have to have this memorized, but for conditional probability to find this, it's the probability of A and B, the probability of both events happening together, divided by the probability of the given event. So let's take a look at some problems here. The situation, we have 12 Oreos in a bag, 7 are lemon, 2 are regular, 3 are mint flavored, and we're talking about grabbing these Oreos out of the bag. And if we're grabbing 2, then we're grabbing 1 out and we're eating it, then we're grabbing the second one. So we're not putting them back in the bag. So it says without replacement. Great. So here, first one, probability of the second draw being lemon, given that the first draw is a regular. Okay? So in order to find conditional probability, we know it's the probability of both of these things happening divided by the probability of the given thing happening. So the probability of getting the second draw being a lemon and the first draw being a regular, well, the first draw being a regular, there's 2 regulars out of 12 Oreos. Sorry, yeah, 2 out of 12. Then there's just 1 regular in there. When we go to draw the lemon, there's now 7 lemon out of the 11 that are left. So we would multiply those probabilities on the top. That's a dependent event situation. And then we divide it by the probability of just the first thing happening, and probability that the first draw is regular was 2 out of 12. Well, because both things are just multiplying on the top, this is as simple as just canceling those things out. This would be a 7 out of 11 probability. So that one seems pretty legit, all right? Moving on to the second one, the probability of the second draw is lemon, given the first draw is mint. Well, we know it's going to be a probability of both of these happening. I'm going to give myself some space and do this one over here. Probability of both of these happening, so that would be the first draw being a mint. There's 3 mint out of 12 Oreos. We eat it, so there's only 2 left of the mint. And then the second one we want to get is lemon. Well, lemon, there's 7 out of the 11. Well, we multiply those because it's a dependent event situation. We're going to divide it by the probability of just the given event. The first draw being mint was 3 out of 12. Once again, because these things are multiplying across the top and we have a factor that's in common with the bottom, we can cancel those things out. This one also has a probability of 7 out of 11. Moving on to this one. Resetting our bag of Oreos, the probability of the first draw is regular, given that the second draw is irregular. Well, we know it's going to be the probability of both of these things happening. First draw being regular would be 2 out of 12. We eat it, so there's only 1 regular left. So for the second draw also being regular, that would be 1 out of 11. We multiply these things across the top because, again, they're dependent events. And we're going to divide it by the probability of the second thing. Sorry, by the second thing, I mean in order here. It's the given. It's given that the second draw is going to be regular, and we know in order for the second draw to be regular, that would be a probability of 1 out of 11. Because the second draw, there's only 11 Oreos left. Once again, we have a factor that's in common in the top and the bottom. Cancel it out. We're left with 2 over 12, which is 1/6. So the probability of this happening would be 1 out of 6. Finally, the probability that the third draw is mint, given that the first draw is mint and the second draw is mint. So we're resetting our bag of Oreos. we know this would be the probability of all three things happening. The third, I'm going to start with the first draw, then the second draw, third draw. First draw being mint would be 3 out of 12. Then I have 2 mint. So the probability of getting a mint the second time would be 2 out of 11. And then I have 1 mint, and the probability of getting a mint the third time would be 1 out of 10. I'm going to divide this by the probability of the given, and the given would be that the first draw is mint and the second draw is mint. Well, the first draw mint is 3 out of 12. Second draw being mint would be 2 out of 11. It's the probability of the entire given. We multiply it together to get those probability of that event. We can cancel out common factors. The probability of this happening would be 1 out of 10. Okay. So that's just one situation we can use conditional probability. Let's look now at a deck of cards. Of course, typical situation, I'm talking about drawing random cards out of the deck. First thing, the probability of getting a queen, knowing that we're going to have a face card. Okay? Well, the probability of A and B, think about that word and, it has to satisfy both conditions. What is the probability of getting a queen and a face card? Where does that overlap? Well, if it has to be a queen and a face card, it's the 4 queens. That is both of those things happening. To be a queen and a face card, you have to be a queen. So the probability of getting both of those things to be true would be 4 out of 52. Given that it's a face card, well, let's look at the face cards. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 face cards. So we're going to divide that by the probability of the given, which is 12 out of 52. Because this is division, I'm going to keep change flip. 4 out of 52 times 52 out of 12. The 52s cancel out. That's 4 over 12, which is 1/3. Okay, that's just one situation. Okay, probability we get a queen given that it's going to be a spade. Well, first, on the top of our fraction, we put the probability of and, the probability of A and B. What is the probability that it's a queen and a spade? Well, out of all the queens, well, to be a queen and a spade, there's only one thing that satisfies both of those constraints. That is the queen of spades. And what was the probability of getting that out of a deck of cards? 1 out of 52. We divide that by the probability of our given. It's given that it's going to be a spade. How many spades are there? There's 13 out of 52. So we keep change flip. 1 out of 52 times 52 out of 13. This gives us 1/13. Okay. The probability that is a heart, given that it is going to be a 7. Well, we again look at both of these things happening at the same time. It's got to be a heart. It's also got to be a 7. There's only one card that satisfies this. This is 1 out of 52. We're going to divide that by the probability of the given. Was the probability that it's a 7? Well, there's only 4 7s in the entire deck, so that would be 4 out of 52. So we keep change flip. So 1 out of 52 times 52 over 4. This comes out to be 1/4. Next one here, the probability it's a number greater than 4, given that it's a numbered card. Okay? Well, again, we look at the probability of both of these things happening together. It's got to be a number greater than 4, so that's 5 or greater, and it's got to be a numbered card. So any of these right here, 5, 6, 7, 8, 9, or 10 would work. And so that is 6 and 4. There's 24 of these. 24 out of the 52 satisfy both. We divide that by the probability of the given. What is the probability that it's a numbered card? Here there's 24. There's 33 numbered cards. Ace isn't a numbered card. 2 through 10. One, 2, 3, 4, 5, 6, 7, 8, 9. Should be 36. Yeah, 36. Okay, once again we keep change flip. 24 over 52 times 52 over 36. That's 24 over 36, which comes out to be 2/3. Finally, probability it's a number greater than 4, given that it's a lettered card. Well, first we look at the probability of both of these things happening together. So it's a number greater than 4. It's also a lettered card. Well, notice that the lettered cards, J, Q, K, or A, don't have numbers. And so there's 0 overlap in these two sets. That's 0 out of 52. Divide that by the probability that it is a lettered card. There's 4, 8, 12, 16 lettered cards. And we have 0 out of 52 times 52 over 16. That's 0 out of 16. That's 0. 0 divided by 8. We could have seen this from the beginning. There's no overlap. So there's no chance. If it's going to be a lettered card, there's no way it can have a number greater than 4.